Alright guys, today we're going to move on to lesson 29 in unit 5, and we're going to analyze numerical data. Basically what we're going to do is we're going to take our histograms, our box plots, our dot plots, and we're going to basically work with them. We're going to find our mean, median, mode, range, MAD, and other information based off those box plots and those dot plots and those histograms. So, let's use what we know. Death Valley National Park in the western United States is known for its extreme temperatures. This table shows how high temperatures for the first 15 days of October. So, we're supposed to use the median and the mean to describe the data. So, use the math we already know to construct a dot plot. So, there you see they have the number line out. All you have to do now is go in and put in your dots for each data point. So, if we do that, we have 99. So we'll come in here and put a dot above 99. We have 88. 71. 113. 88. 80. 99. 90, 79, 97, 84, 84, 91, 81, and 96. So, your dot plot should look something like that. So, B says, describe the shape of the data. What does the shape tell you about the temperatures? So we're going to go back to lesson 27 where it gives us all of those vocab words, and we're going to use those words to describe the data. So, first thing we're going to talk about is how we go from 70 to 113. So, we can say that the data points, let's use a pen. Are spread out. They are not all grouped together. We can say that most are between 80 and 100 degrees. Okay? We're basically just explaining what it looks like. Tell me about it. There's not really a peak anywhere, so we can't say anything about that. There's not really a cluster because it is pretty spread out, but if there is, we would say that it would be the 80 to 100. We just tell what the data looks like. C, do you notice any outliers? Well, do we have any data points that are kind of out by themselves? Yeah, we kind of do. We have 71 and 113. And we can say because they are away from the rest of the data points. What is the median temperature and what is the mean? So if we're going to go through and find the median, basically I'm going to find my middle number. So once I have my dots and my dot plot, we know that there are 15 days, so I'm going to find my middle number, which is going to be the 8th number. So if I count in my 8th dot, we would see that 88 degrees Fahrenheit is our median. For the mean, I'm going to add them all up. When I add up all of my temperatures, I get 1,340, and then I would divide that by 15. When we do that, we get a decimal, and it's 89.3 degrees Fahrenheit. So, E says, what's similar about the mean and the median, and what's different? Well, the mean and the median are similar because the data is spread pretty evenly. There's not one area that's way more than another. They're all pretty equal along as we go. Then we can say The difference is the mean is slightly higher, and we know back from when we talked about the mean that it is because of the outlier 113. The 113 is further away from the data points than the 70 is, or the 71. So the 113 affects it a little bit more than that lower outlier. So let's find out some more. What would happen to the median and the mean if you eliminate the outlier and replace it with a less extreme temperature like 100? The data set and dot plot would look like this. So you can see that they took out the 113 and they changed it to 100. So when we replot these, you can see that we added the 100 there and took away that 113. So when we do that, our middle number doesn't change. We still have the same amount of data points. Just because that last value changed does not make the median any different. Our middle number is still going to be 88. The mean, however, does change. It changes from 89.3 to 88.5. In this context, the outlier influences the mean, but not the median, which we've talked about. So, explain why outliers affect the mean. Well, we've talked about this before. High outliers pull the mean up. Low outliers pull the mean down. So let's look at another one. Consider the first set of the Death Valley National Park temperatures that you saw. What does the interquartile range tell you about the variability of the temperatures? So now we're basically looking at our quartiles and our median. So we need to find all of our information. So we start with our median, and we see it was 88, which means the middle of everything below it would be 81. The middle of everything above it is 97, and then our high and low temperature is 71 and 113. So we can put that into our box plot. We drew our points at all of our numbers, and then we connected our first and third quartile. So when we go to find our range, we're going to take those two numbers and subtract them. So calculate the IQR. What does it mean within this context? So if we're going to calculate the IQR, we're going to take our third quartile, which is 97, and we're going to subtract our first quartile, which was 81. So 97 minus 81 gives us 16 degrees for our IQR. This means the middle 50% of the data has a range of 16 degrees. Because remember, the box is the middle 50%. Number 3, look at the box plot. How many data points are represented by the box? What does this box mean? Well, there are 9 data points represented So that means that half the data points fall between 81 degrees and 97 degrees. So basically that middle 50%, there are 9 data points that are between 81 and 97. So that's what's represented by the box. That means that since the box is 50%, that half of those data points fall between those two numbers. Number 4, if you replace the outlier 113 with 100 degrees Fahrenheit, what happens to the IQR? Well, if we're looking at our highest number being 113 and it drops to 110, does that affect our IQR? Well, no. The IQR will not change. Because the upper and lower quartiles, or the first and third quartile, remain the same. Okay, when we change our highest number, it does not affect our upper and lower quartile. The overall range will drop because the highest number is lower. Okay, so when we're changing like our higher and lower number, it does not change our interquartile range because our quartile numbers will stay the same. So number 5 says, within this context, explain what the median and the IQR tell you about the data. The median tells you that 50% of the data are higher or lower. Okay, so your median's your middle number. You have 50% of the data that's lower, you have 50% of the data that is higher. The IQR gives you the range of the middle 50%. So the IQR just tells you the middle of your data ranges from here to here. So take a minute and I want you to try it. Use what we talked up above about IQR and the median and answer number 6. Are the median and the IQR typically affected by outliers? And then explain. So think about what we talked about up above. How do your outliers affect? Okay, so like we mentioned earlier, median and IQR are dealing with the middle of your data. Outliers are not a part of the middle of your data. They're going to be out on the edges by themselves. So, are the median and IQR typically affected by the outliers? No, they're not. Because outliers are not usually in the middle of the data. They're going to be out on the edges. They're not going to be in the middle. And the middle number and the IQR, which is your middle 50%, are not usually anywhere besides the middle. They're not going to be out on the edges. Okay, so let's talk about the MAD a little bit. Consider another way to describe the Death Valley National Park temperature data. Calculate the mean absolute deviation. What does the MAD tell you about the variability of the temperatures? So once again, here's our temperatures. So when we plug these in, we have our actual temperature, and then we have our absolute deviation, which is where we took our temperature and our mean and subtracted them. And then we add them all up and divide by the number we added to find our average away from our mean, or our MAD, as 7.95. So, what does the MAD mean within this context? Well, basically it's telling us that the data points or the temperatures, vary 8 degrees from the mean, which is 89.3. So number 8, given this context, does the MAD value indicate a high or low variability? Well, the MAD is 8 degrees, so that indicates a high MAD, or a high variability. Okay, so when we think about it, 8 degrees is a pretty high temperature difference. Okay, so if we think, the temperature at 50 degrees and the temperature at 58 degrees, well, 58 is almost 60 degrees. 60 degrees is fairly warm, but at the same time, 50 is kind of chilly. So 8 degrees when you're talking about temperature is a pretty high difference. Number 9, if you replace the outlier 113 with 100 degrees Fahrenheit, what happens to the MAD? And then explain. Well, when we change those, it affects our average. It makes our average go down because the outlier is not as high. It's not an outlier anymore. So if it affects the mean, the MAD will also be affected and will go down. Oops. And the reason is because the total amount of differences will decrease. Number 10, within this context, how are the mean and the MAD different, and how are they related? The mean is a measure of center. If all data points were equal, the temp would be 89.3 degrees. The MAD is a measure of variability. The temperatures are an average of 8 degrees away from the mean. Okay, so the mean gives us our middle. It measures the center and tells us about what all of them are, but your MAD is telling how far away they are from that average. Okay, it's a variability showing how much it varies. So, once again, I want you to try it. Are the mean and the MAD typically affected by outliers? So, think about what we've talked about in the past. Write your answer down. Okay, so, are they affected by outliers? And explain. Well, we've talked about this before. The mean is affected by outliers. So, we say yes, because outliers make the mean higher or lower. And if the mean is affected, that affects the MAD. When the mean changes, it changes the MAD. Okay, so if our mean changes because of an outlier, if it goes higher or lower, then that affects the MAD because the MAD is based around the average or the mean. So yes, they are both affected. So now I need you to get back into classroom and I need you to work on the exit ticket. Make sure you submit it when you are done.